In this demo, we present FactDM, a framework for cost-based data models transformation. This framework guides system information architects in their data model choice process, and it consists of three different components: data models generator, multi-dimensional cost calculator, and a visualization tool. The user starts by providing inputs, which are conceptual model, use case queries, and multiple settings such as data volume, number of servers, queries frequencies, etc. Then data models generator component uses these inputs to generate a set of possible data models for this use case. The visualization tool component displays these data models in the form of a graph, and the multi-dimensional cost calculator component calculates costs for each generated data model. Finally, the visualization tool uses these costs to display or to position these data models in a two-dimensional chart with respect to their time and environmental costs. The data models generator starts from inputs provided by the user and uses heuristics and transformation rules recursively to generate all possible data models for the input use case. In addition to the generated data models, which are in XML format, a signature file is generated. Each two lines correspond to one data model, where the first line is its unique signature that describes its structure, and it is used as its ID in our visualization tool component. The second line is the path of transformation rules applied to get to this data model. In order to understand how these signatures were generated, we take the example of this data model with three rows: warehouse, customer, and order, each one of them with different number of keys, where primary keys are in bold. The generated signature is as follows: customer, order, and warehouse rows with their different keys between braces, and the last two elements are the relationships linking primary keys to foreign keys. In this demonstration, we have proposed a framework with three components: a data models generator that helps to generate a set of possible data models for an input use case, a multi-dimensional cost calculator that calculates time, environmental, and financial costs for these data models, and finally a visualization tool that helps to visualize these data models and to change different settings to see their impacts on the costs, which we will see in the following. In addition to the conceptual model and the set of use case queries provided by the user, they can also define the different settings in this box, such as data volume, number of servers. They can define the different queries frequencies, and the max execution time here is the time constraint defined by the user that all data models should respect. Using these settings, this is the graph that was generated, where the nodes are the data models, the edges are the applied transformation rules. We see that it's positioned in a two-dimensional chart with respect to the time and environmental costs of the different data models. If we click on this node, for example, we have its information that appears to the right. So we have its ID, which is its unique signature. We have the parent node signature and the transformation rule applied. This helps us to know that in order to get this data model that we clicked on, we had to apply a split transformation rule on the parent node. We also have the time, environmental, and financial costs of this data model. We have the different time queries of the different time costs of different queries on this data model. And to the bottom here, we have graphs information, which are graph statistics. So we calculate min, max, and average costs of different data models of this graph. To the top here, we have a search box that helps us to find an exact data model in the graph using its ID or its signature. So if we look for this data model, for example, it will take us exactly to where it is in the graph. We notice that nodes are colored differently, and we have used an RGB system to color them: red for time, green for environment, and blue for financial costs. The nodes with lighter colors are the most cost-effective ones, and the ones with darker colors are the ones with higher costs. The nodes that are colored in gray are the ones that were not considered by our data model generator component because they were either redundant or they were not useful for the use case. We can vary the different settings to see their impact on the costs. So if we vary the data volume, for example, we start seeing the costs growing, and we notice more change in terms of time costs. Now, if we change the number of servers, we start seeing more impact on the environmental cost of data models. We can also change queries frequencies, and we see how that impacts the cost as well. Data models framed in red are the ones that don't respect the max execution time constraint defined by the user.